Hello everyone. Today I will be discussing the topic mechanism of polymerization reaction. Let us see how the term polymerization is defined, the process by which a monomer molecules are linked to form a big polymer molecule is called polymerization. This is a very basic thing and it needs no explanation. Let us go into the classification of polymerization reaction mechanism. It is broadly classified into two. One is step growth polymerization, which is also known as condensation polymerization, and the other one is chain growth polymerization, which is also called as addition polymerization. Let us see one by one in detail. First, let us start with step growth or condensation polymerization. In this slide, you can see some of the features of step growth polymerization. The most important one is there is only one reaction mechanism for the formation of a polymer. This is not in the case of chain growth polymerization, and that we will see later. Second feature is any two molecular species present can react, and the growth of polymerization or the polymer growth takes place very slowly, whereas in chain growth polymerization the growth rate is very rapid. Another feature is the molecular weight rises steadily throughout the reaction and high conversion is required. This is a most important example for condensation polymerization, that is a reaction between adipic acid and hexamethylene diamine to give nylon 6,6. Here both the monomers are difunctional monomers and also there occurs the loss of water molecule. The loss of small molecules like water, ammonia are common in step growth polymerization, and that is the reason why it is also known as condensation polymerization. Now let us have a look into addition or chain growth polymerization. It is classified into two, that is radical polymerization and ionic polymerization. Ionic polymerization is further classified into cationic and anionic. That we will see in detail, but here the point that we have to remember is in addition polymerization, the mechanism involves three steps, that is initiation, propagation and termination. This is a most important example for condensation polymerization, that is a reaction between adipic acid and hexamethylene diamine to give nylon 6,6. Here both the monomers are difunctional monomers and also there occurs the loss of water molecule. The loss of small molecules like water, ammonia are common in step growth polymerization, and that is the reason why it is also known as condensation polymerization. Now let us have a look into addition or chain growth polymerization. It is classified into two, that is radical polymerization and ionic polymerization. Ionic polymerization is further classified into cationic and anionic. That we will see in detail, but here the point that we have to remember is in addition polymerization, the mechanism involves three steps, that is initiation, propagation and termination. Before going into the mechanism, let us have a comparison between radical and ionic polymerization. The first one is reactive species. As the name suggests, in free radical polymerization, the reactive species will be a free radical, whereas in ionic polymerization, it can be either a carbanium ion or a carbanion. The second one is the type of monomers used. In radical polymerization, any type of monomer can be used, whereas in ionic polymerization, selective monomers can only be used. That means in cationic monomers, alkenes with electron donating groups are preferred, for example styrene, whereas in anionic polymerization, alkenes with electron withdrawing groups are preferred, for example acrylonitrile. The third point is the effect of solvent polarity. The solvent has no effect for radical polymerization, but it has a significant effect in ionic polymerization. Usually highly polar solvents like water, alcohol, what happens is they react with the initiator and it results in the termination. So usually solvents with moderate polarity is preferred. The fourth point is the nature of reactions. Radical polymerizations are usually simple, where in ionic polymerization they are complex and fast. Fifth point is termination. Biomolecular termination, that is the mechanism of radical polymerization. Whereas in ionic polymerization, we need some external agents to terminate the reactions. Now let us have a look into cationic chain polymerization. As we have seen already, almost all monomers with electron donating substituents can be used as cationic monomers. The role of electron donating substituents here is that it must be able to stabilize the positive charge. So, the active sites are either carbenium ion or oxenium ion. That means the positive charge can be present either on carbon or on oxygen. Here we have taken the example of styrene. The resonating structures of styrene are also drawn where we can see that the positive charge ion, when CH3 CH double bond CH CH3 reacts with HBr, a carbenium ion is generated. The second step is propagation. Once a carbenium ion is generated, it reacts with the monomer to form the polymer chain. The growing chain always possesses a positive charge, and sometimes rearrangement takes place, and that is based on the stability of carbocation. It will always have a tendency to form the more stable carbocation. This is the final step, that is termination. It can occur by different methods. One is by proton transfer to monomer. Here what happens is that you can see that one is the carbenium ion and the other one is the monomer. Here what happens is the transfer of a beta proton to the monomer. In this the first one is the carbenium ion, its beta proton is transferred to the monomer, and we will get the resulting structure, and it results in the termination. Another method of termination is by hydride ion transfer. This is different from the previous method, because in the previous method it was the proton that was transferred to the monomer, but here it is the hydride is transferred from the monomer. Okay. Another method of termination is proton transfer to counter ion. The counter ion is a nucleophile that is mentioned here. When the proton is transferred to the counter ion. Now let us look into anionic polymerization. In anionic polymerization, vinyl monomers with electron withdrawing groups are used. In initiation step, all we have to do is to generate a carbanium ion. That can be done by different methods. Usually a base initiator or an organometallic compound or a salt of a strong base reacts with the monomer. In the propagation step, okay, the carbanion which we have generated by the initiation step reacts with the monomer, and we will generate a polymer chain. In this slide, we can see how a polystyrene is generated. That is, a secondary butyl lithium is made to react with a styrene monomer under certain conditions, and a certain product is formed, and further monomer is added, that is the styrene monomer is again added. This is how the chain growth happens. Okay. The last one is termination. Here we can see the spontaneous termination via hydride shift. We saw the termination via hydride shift in cationic polymerization also. Similarly, okay. Now let us look into free radical polymerization. The first step is initiation. This is supposed to be the first slide, that is the formation of a free radical. Here what happens is the initiator undergo homolysis. Benzoyl peroxide is what we have used here. It undergoes homolysis to generate the free radical. Another example is of AIBN is also given here. In both the cases, we generate a free radical. In propagation step, the reactive intermediate is continuously regenerated during the course of reaction. Here what happens is a monomer is added to the initiated monomer species, and the process continues until termination takes place. Now termination can happen by two methods. One is by coupling and the other is by disproportionation. In coupling, we get a saturated molecule and it terminates the growth of the polymer chain, whereas in disproportionation reaction, a saturated as well as an unsaturated molecule is yielded, and thus it terminates the reaction. Okay. This is all about free radical polymerization. This is the last slide, which gives a comparative study about chain growth polymerization and step growth polymerization. The most important point that we have to remember is, in chain growth polymerization, it is the formation of polymers from unsaturated monomers, whereas in step growth polymerization, it is the formation of a polymer from bifunctional or multifunctional monomers. And in chain growth polymerization, we have three distinct steps, that is initiation, propagation and termination, whereas this is absent. There is only one mechanism in, one reaction in step growth polymerization. I hope it is clear to all of you. Thank you.